Hello, everyone, and welcome back to ACCS8. Hope you all had a good break. And let's move on to the third talk session of ACCS8. And for that, let me introduce to you Dr. Devpriyakumar of IIT Kanpur. Dr. Devpriya is an assistant professor at the Department of Humanities and Social Sciences, IIT Kanpur. And he works in the field of perception and cognition and got his master's degree in cognitive science from the Center of Behavioral and Cognitive Sciences, University of Allahabad in 2009. And he got his PhD in cognitive science as well from Center of Behavioral and Cognitive Sciences from University of Allahabad in 2015. He achieved a graduate student scholarship from the University of Allahabad in 2009 to 2014. And he's interested in emotional perception, intentionality, control system approach in cognition, and complex systems, motor control, attention control, and sense of self. I invite you, sir, to chair the third talk session of ACCS8. And I would also like to invite Mr. Sandeep Bodda from Amrita Mind Brain Center to co-chair the session.
Thank you.
Okay, thank you so much. So let me start the first presentation. So the first presentation is titled, Does Case Marking Influence the Timing of Verb Retrieval During Sentence Production? It has been authored by Mudaffia Zafar and Samar Hussain. Both are from IIT Delhi, Department of Humanities and Social Sciences. Mudaffia will be presenting the paper.
Good morning. The study that I'm going to talk about today is part of my ongoing PhD research supervised by Professor Samar Hussain. The study investigates if case marking influences the timing of verb retrieval during sentence production. I shall begin by giving an overview of the study. So speaking requires converting a nonverbal message into linguistic form. For example, if I have to describe what is going on in this image, I could do this in a language like English with the following sentence. The girl is calling the wrestler. The word order of the sentence here is subject, verb, and object. In contrast, if the same image has to be described in a language like Hindi, then I could use the following sentence. Bachchi pehelwan ko pukar rahi hai. The word order here becomes SOV, with the verb being the final most element of the sentence. Based on these typological differences between languages, one of the key questions in sentence production is how are these elements planned in real time? What is the nature and scope of planning during speech? In this work, we look at verb planning. More specifically, we investigate when is the verb retrieved during sentence production. So there are two views on the timing of verb retrieval. According to the first view, verbs are needed in order to grammatically formulate the arguments, that is the subject and the object of the sentence. Hence, it becomes crucial to retrieve the verb early, that is before the formulation of any of the arguments of the sentence. In contrast to this, the other view states that arguments can be grammatically encoded verb independently by relying on the conceptual message of the sentence, and you do not need to retrieve the verb early. Instead, the verb can be retrieved on a just-in-time basis prior to its position of articulation in the linear order of the sentence. However, recent studies have found mixed evidence in support of the two views mentioned above. For example, Huang and Kaiser found that verb retrieval can vary based on the typological properties of the language. For example, verbs are retrieved early for an SVO language like English, but retrieved on a just-in-time basis for an SOV language like Korean. In contrast to Huang and Kaiser, Moma et al. Found that the verb is retrieved neither early nor on a just-in-time basis, but rather before the internal argument, that is the object of the sentence, for both an SVO language like English and an SOV language like Japanese. In the current study, we intend to test these divergent hypotheses via the property of split ergativity in Hindi. So Hindi is an SOV language where arguments precede the verb and these arguments are case marked. Critically, there is an aspect-based split to the case that is assigned to the subject. In the perfective aspect, subjects of transitive verbs take up the ergative case marker, which is ne. So for example, we have something like Bachchi ne pehelwan ko pukara. However, in the imperfective aspects, the nominative case, which is phonologically null, appears on the subject. Example, बच्ची पहलवान को पुकार रही है. However, perfectivity alone does not guide ergative case assignment in Hindi. It is also to a certain extent dependent on the idiosyncratic properties of the lexical verb. For example, there are a few verbs such as mill, meet, or la, bring, which do not take up the ergative marker even in the perfective aspect. Instead, they take up the nominative case. So, for example, we have a sentence like बच्ची पहलवान से मिली और बच्ची फल लाई. In contrast, nominative case assignment in imperfective aspects is more regular, and such idiosyncrasies are not observed. Based on this, the hypothesis that emerges is that if ergative case assignment is dependent on the lexical verb, then verb retrieval must precede the formulation of an ergative case marked subject. In contrast, since nominative case assignment is more regular and such idiosyncrasies are not observed, nominative case can be assigned to the subject based on conceptual knowledge of event telecity, that the event has been completed, and early verb retrieval might not be needed in such a scenario. This question was investigated via the extended picture word interference paradigm. Participants described images of transitive events in simple sentences, and their descriptions were recorded. Superimposed upon the images were words that were either semantically related or semantically unrelated to the target verb. It has been found that participants are slower to begin speaking in the related distractor condition as compared to the unrelated distractor condition. This is known as the semantic interference effect. This happens, the interference effect happens because related distractors create a delay during lexical retrieval, whereas unrelated distractors do not. Related distractors create a competition during lexical retrieval, while unrelated distractors do not, and this competition is what gets reflected in the delay in beginning to speak. So it follows from this that if we find or if we observe an interference effect at speech onset, then this would be indicative of early verb retrieval. The experiment had a 2x2 factorial design with case type as a between subject factor and distractor type as a within subject factor. Case type had 2 levels, ergative and nominative, while distractor type also had 2 levels, related and unrelated. A total of 60 participants, 30 for each case type, participated in the experiment. The number was decided beforehand based on a power analysis. The ergative group participants were instructed to describe the images as if the event has been completed, leading to the use of the ergative marker on the subject, while the nominative group were instructed to describe the image as if the event is going on, leading to the use of the nominative marker. The dependent variable was the speech onset latency. There were a total of 12 items or 12 transitive verbs. Each word was paired with a related and an unrelated distractor. Only those distractors that showed a reliable interference effect in 2 norming studies conducted prior to the experiment were included. The subject was always the first word in the sentence. The predictions related to the study were pre-registered before data collection began on OSF. We had the following predictions. If case modulates verb retrieval, then we expected to find a statistically significant interaction between distractor type and case type. That is, we expected to observe a semantic interference for the ergative case condition and not the nominative case condition. By interference here, I mean that the related distractor condition should be slower as compared to the unrelated distractor condition. However, if case does not modulate verb retrieval, then there could be 2 possible outcomes. Firstly, it could be the case that the verb is always retrieved early in Hindi, irrespective of case type. In that situation, we expect to find a main effect of distractor type, that is an interference effect in both related as well as, interference effect in both ergative as well as nominative case conditions. The other possibility is that verbs are not retrieved early in Hindi. In that case, we expect to observe a null effect of distractor type, that is no interference in either of the case types. Also note that we are agnostic as to where else in the sentence is the verb retrieved, if not at speech onset for this particular study. So the results of the experiment are as follows. We did find an interference effect for both ergative and nominative case types, that is, the related condition was slower than the unrelated condition for both case types. However, the mean difference between the two conditions were different in the case types. In the ergative case, the mean difference between them was 58 milliseconds, whereas in the nominative case, it was 40 milliseconds. All statistical analysis was done using linear mixed models. The dependent variable was log transformed prior to analysis. We fit maximal models followed by model simplification in case of convergence or estimation failures. This is the model output for the first analysis, where we had case type, distractor type, and the interaction between them as predictor variables. And as can be seen, that only distractor type was statistically significant with a t-value of 2.9. The interaction was not statistically significant. Based on this, based on these results, it would indicate that the verb is retrieved early for both case types, that is for both ergative and nominative case conditions. However, we conducted a further analysis where where the effect of distractor type was nested within case. What we found there was that the effect of distractor type was significant only in the ergative case condition and not in the nominative case condition. And this was what was actually driving the main effect of distractor type in the first model, in the output of the first model. So based on our results, we make the following conclusions. Firstly, we conclude that the verb is retrieved early during ergative case conditions, and the verb is not retrieved early in the nominative case conditions, and as it was indicated by the nested contrast analysis. However, given the lack of interaction and our conclusion being based on the null effect, the timing of verb retrieval in nominative case needs to be further explored through a replication study or through the use of an alternate paradigm. And this is what we intend to take up in the near future. That's it. These are my references. And thank you.
Okay. So is the speaker here? Right?
Yes, sir, I'm here.
Okay. So are there any questions? Please, you can just raise your hand or send it to me via chat. So meanwhile, I'll ask a question. So Mudafir, so when you're talking about your predictions, right? There were, in the absence of interaction, there were two situations that you talked about. Maybe I misunderstood the predictions themselves. So first one was the fact that maybe the verb is processed early. And the second idea was that most probably the case marker is not interacting with the distractor information, right? So how do you tease apart between these two hypotheses?
Situation. So the interaction is a situation where we expect that the second factor, which is the distractor type, is going to be significant only in one of the case type and not in the other case type, and that is where we expect to see an interaction. And the other scenario is where we expect to observe a main effect of either distractor type or no effect of distractor type at all. And this is how we tease apart. So if we observe a main effect of distractor type, by main effect, I mean that the related distractor condition will be slower than the unrelated distractor condition in both the ergative as well as the nominative case conditions, then that would be indicative of a main effect of case and early retrieval for both conditions. Whereas if we don't see any effect at all in either of the case types, then that was what I was arguing for the null effect.
So a second thing that was not clear to me was, so basically the interaction between the two was not significant in your result, but then you still went ahead and did a segregation of the two case types and then looked at the effects themselves, right? So one of the things that I was wondering was why exactly was the interaction not significant? Because this was a study that was pre-planned, right?
Yes, sir.
So
So the interaction being significant was not what we had predicted. What we had done our power analysis on was based on a norming study, and based on the effect size, we planned how many number of participants would we be needed to be able to detect this difference. So that was the number 30 for each case type. And the reason that we find that the interaction was not significant, because if we see that in the ergative case condition, the mean difference between the related and the unrelated was 58 milliseconds. That is, the related was 58 milliseconds slower. Whereas in the nominative case, the difference was still, there was an interference effect that still existed, but the difference was slower. The effect size was slower, which was 40 milliseconds. So there was a lesser effect size, but it still persisted. So that is why when for an interaction to be significant, the difference between A and B, that is the first two levels of the first factor, should be significantly different from the other two, which was not the case because there was still an effect size even for the nominative case condition. However, what the nested contrast analysis showed us that individually, when we divided or segregated in that situation, only the ergative case condition was statistically significant. As two separate experiments, if we consider the ergative and nominative, then only ergative one showed us an interference effect which was significant. And that is the reason, because there was an effect in both cases. That is what we hypothesized. That is the reason why we didn't observe an interaction.
Okay. So thank you. So are there any other questions? Okay. So thank you so much for the presentation.
Thank you, sir.
Okay. So I'll invite the next speaker. So the next paper is titled "Consciousness is an Invention, neither a hard, neither an easy problem, never an illusion. Consciousness, it's not the explainendum. Consciousness is the explainers." The author is Vitor Manuel from Language, Mind and Cognition Research Group, University of Lisbon. So I request recording to be started. So if there are any questions, please just send them to me via chat and I'll ask them at the end.
Consciousness is an invention, neither a hard, neither an easy problem, never an illusion. Consciousness, it's not the explanandum. Consciousness is the explains. So, imagine an old-fashioned switchboard with just two toggle switches. Each time you flick one of those switches, you open a path that sends the debate in a different direction. Let's say the first switch determines whether or not subject and object to be considered separate, the second whether or not the subject is to be supposed physical. Two toggle switches means just four available pathways. Let's start by turning our first switch in favor of a separation of subject and object. With the first switch on separate, we now have to set the second. If we set it for a subject that is non-physical, then we get Descartes' immaterial, a spiritual subject. That is, in the Cartesian model, we have the material souls, just selves if you like, separate from the physical objects we experience and even ultimately from our bodies. It's a solution that has occupied a huge space in modern history and that many religions endorse, but scientifically it's a non-starter since it's based on the notion that the subject cannot be an object of scientific inquiry. So we can be forgiven, I think, for paying it no further attention. We now flick that second switch to physical. Things hardly get much easier. This is the territory, I should say, of modern science from Galileo right up to today's neuroscientists. They left the first switch set to keep subject and object separate, but placed the subject in a predetermined place in the physical world, namely the brain, and hence made consciousness a neural process that is inside the head and separate from the physical world it perceives. Unfortunately, since all available empirical findings have shown that the properties of neurons are nothing like the properties of our minds or our experience. This shows every sign of being another dead end. Time to go back to the first switch then and set it for subject and object that are not separate. The inactivists toy with the first switch without actually turning it all the way to not separate. They see that consciousness can't be reduced to a property of the goings-on in the brain, so they start to look outside. But instead of considering the external object as such, they look at our dealings with the object, our handling the object, our manipulating the object, believing that consciousness is a product of the actions we perform. At the end of the day, though, the object remains doggedly separate from the subject who experiences it. And unfortunately, actions, whether they be eye movements, a touch, a chewing, are no better than neural firings when it comes to accounting for experience. Okay, let's stop playing with that switch and set it determinedly on subject and object not separate. As for the second switch, let's again start with a subject that is not physical. This is the territory of Bishop Berkeley and Leibniz in the late 17th and early 18th centuries. Crudely speaking, they proposed that subject and object become identical, the same thing, but both in a completely non-physical world. Identical in the same way that Bruce Wayne and Batman are identical. Bruce Wayne is Batman. For a true idealist, that's what this approach is called. The object of perception is nothing but a modification of a part of the subject who experiences mental representations or ideas which are not physical. The world is all idea. Actually, you could say that this position has recently been revived by techno-enthusiasts like Elon Musk who wonder whether we live in a giant computer simulation concocting the illusory objects we erroneously imagine reality is made of. These are intriguing ideas, but again, they're scientific non-starters since they depend on a non-substance which no one can track down or verify. You can't even begin to prove them wrong. And I guess we've reached that point. 3 of our 4 pathways have been dismissed, so let's turn to the last. First, switch on not separate. Second, on physical. That is, subject and object are identical, the same thing, and physical. The only philosopher I can think of who has given a nod in this direction is Aristotle, when he says that the mind is in a way all existing things. Take a really ordinary situation, a person looking at some everyday object, let's say an apple. So, we have a body, including a brain of course, and an apple. Nothing esoteric or improbable there. The body, let's say your body, on the left, the apple on the right, thin air in the middle. What could be simpler? But there's still one piece of the jigsaw we haven't placed yet. Your experience, simply the experience of the apple. Where is that? And what is that? We can't account for it. So let's consider the chief suspects, one by one. Is it the activity of your neurons? There is nothing appish in the gooey brain, and anyway, we don't experience neurons. We experience the apple. So is your experience a movement you're making in relation to the apple? Some action. Is it your movements that conjure a sort of applichness? Movements, actions, don't seem to have anything in themselves that we can identify with the apple we see. I can't imagine a robot repeating exactly my movements would have the same experiences I have. I think we can let this go. So could our experience of the apple be an amalgam of everything going on between subject and object? neural processes, retina, optic nerve, molecules, apple, atoms in the molecules, electrons in the atoms, everything. Because just as we don't experience neurons, so we don't experience retinas or photons either. Obviously, they're necessary to the experience of seeing an apple. All the elements of the process are necessary, but they're not it, are they? The constituent parts are casually necessary the way a pot is necessary to boil pasta, but the pot is not the cooked spaghetti. Nor is the heat source, nor is the water. In the case of the apple, if you list the properties of the process as a whole, they just don't match the properties of the experience. Photons are not applish. The rhodopsin your retina secretes is not applish, and so on. When I experience the apple, I'm not aware of experiencing the other various elements of the process. Okay, but meantime, what if someone said that the experience was the apple itself? After all, the apple is definitely the most applish thing around. And the only thing that has the properties of an experience of an apple. It's round, it's red, it's shiny. So, why can't the subject, consciousness, but not the body, notice, be identical with the apple out there where the apple is? Consciousness is not about the apple. Consciousness is the apple. Essentially, my experience of the apple or any external object is outside my body, out there where the object is. The apple was out there, and so it is. And with it your experience. My experience is literally the object. So my consciousness, the subject, or at least the part of me that is the experience of the apple, is identical with it. All that we know about what goes on in the brain, all the correlations between neural activity and specific kinds of perception, all the physics of photons and sound waves, all the chemistry of retina and taste buds, all the mechanics of the ear and the nose remain absolutely in place. Everything is physical, verifiable. We just have this one admittedly enormous conceptual shift. Instead of supposing that the senses receive input and somehow create a second inner mental world reflecting the outer world, we say that your experience is in the outer world. It is not separate from the physical object you perceive. It is the object. Francis Bacon remarked that opportunity makes a thief. Likewise, we could say that your body offers the opportunity of physical conditions, eyes, optic nerve, neurons, and so on, that allow the world to take place as the object we experience. The apple conjured up by this opportunity that is your body. The apple you perceive is not an absolute apple. It's not the apple that Galileo supposed was altogether measurable and fixed, nor Kant's noumenon. The apple in itself that can never be known. It's not an apple in an X-ray machine, nor a slice of apple under an atomic microscope. The apple that you experience is simply a selection, a subset of the many other things going on out there in the world. It is the selection that your body, your brain plus your sense organs allow for. Your apple is not a snail's apple, or a bat's. Your apple is made of those and only those physical features that cause effects thanks to your sensory organs, your particular body, which is not to say that other properties do not exist. They do. It's just they're not part of the object that you experience, with one side of a shiny red round apple. So I am the apple. Of course that sounds absurd, because you identify your conscious self, the subject, the I, with your body, and your body is clearly not the apple. But what if I were to say that the very idea of consciousness was invented to explain how you could experience an apple when there is no apple in your head? So we have to have this consciousness apple. However, if experience and apple are one and the same, there is no longer any need to talk of a consciousness separate from it. The apple is more than enough.
Okay, so I guess that's the end of the presentation. Thank you so much for the presentation. We won't be able to take any questions because we have already crossed the time limit. We'll move on to the next presenter. So the next paper is titled On-Center Off-Surround RNN Model for Enumeration in Natural Images Using Saliency Maps. The authors are Bhavesh K. Verma, Raju S. Bapi, Ravichandran Janapati, and Rakesh Sen Gupta. They are from the Center for Creative Cognition, SR University, Telangana. Bhavesh will be presenting the paper.
Good morning, everyone. Can you hear me?
Yes.
Myself, Bhavesh Verma. I am a master's student at ISR Pune. This presentation is based on the research work that I am doing at the Center for Creative Cognition, SR University. We are working on a visual enumeration model based on an on-center off-surround recurrent network. At present, most of the visual enumeration models are based on deep learning, which often fails to prove themselves biologically relevant. A good computational model...
Bhavesh, sorry for interpretation. We can't see you the screen of yours.
You can't see the screen. Oh. 1 second. Are you able to see it now?
Yes.
Okay. Thank you very much. A good computational model should try to emulate some of the behavioral findings regarding number perception, such as Weber fraction, reaction time, influence of change in object size and density, and adaptation effects. Before going to the model, let's find out what saliency maps are. Saliency map of an image highlights the region on which people's eye focus first, and hence, in a way, it captures the region of most importance. For our image enumeration task, saliency maps can be useful as it can highlight spatially separated objects. We have tested some of the already existing saliency map algorithms. The most popular one are listed below. Our model can be divided into 3 major parts. In the first step, we generate saliency map of an image. Then we modify the data to fit the format for the neural network. In the second part, we feed the data to an on-center off-surround neural network. After the network dynamics reach a steady state, we take the mean activation of the network as the output for this step. In the third step, we use this mean activation to estimate the number of objects present in the original image. I will try to explain each of these steps in a little bit more detail in upcoming slides. So in the first step, we take an image and generate a saliency map by already existing algorithms. Here in this image, we have used Raya 2012 saliency map. Then we apply a threshold value below which every matrix value gets to 0. This reduces the noise, background noises. Then we resize and normalize the values to fit into the parameter of the network. We are using a network of 64 size, so that's why we are converting it into 8x8 matrix. At the core of our model, we are using a biologically inspired recurrent neural network. Every neuron in this network tries to activate itself and inhibit all other neurons. That's why it is called on-center off-surround recurrent neural network. To simulate the dynamics of the network, the given differential equation is used, where alpha is self-excitation strength and beta is mutual inhibition strength. And I is the input from the saliency map. For a small duration, this network is injected with an input current based on the data from the saliency map. After the network dynamics reaches a steady state, the mean activation of this network is taken as the final output, which is later used to estimate the numerosity of images. Here is the table which shows the network parameters that we're using for the simulation. Here, strength of self-excitation is 2.2 and strength of mutual inhibition range from 0.01 to 0.15. We have used the same network with different inhibition strength. In the previous studies, it is seen that the same network have different behavior for different inhibition strengths, and they have. I'll show it in the next slide. Here is the relation between set size, which is a manual injection of input number to the network, and the corresponding mean activation. Here we can see that for a network with low inhibition value, which is 0.01, the set size from 20 to 60 shows monotonic relation between mean activation, and this region is monotonically increasing. But in the network with a little bit more inhibition strength, the monotonic relation is between 0.0 to 7 and the mean activation. So we have found out that the relationship is monotonous. We can use the data to, we have found out that if the relation is monotonic, then we can use the data to estimate input number from the mean activation by taking some inverse function of this relationship. From the step 2, we have mean activation as the input. Our algorithm chooses the inhibition parameter, which varies monotonic to that region and have the highest sensitivity to change in the input number. Then we use local linear fit on the curve as a functional relation between the input number and mean activation. The inverse of this local linear function is then later used to, when we feed the mean activation to the inverse of this function, we get the estimation of numerosity. Here is a diagram showing the end-to-end process of the algorithm. The data from saliency map in the first step is used as the input current for the RNN. Here in the first part of this image, we can see the first step. In the second part, we have used two different inhibition strength, 0.15 and 0.05. Mean activation of the both network is used in the third step to predict the numerosity. In the first case, it comes out to be 2.2, which gets rounded up to 2. And in the second case, it comes out to be 6.4, which gets rounded up to 6. We have seen that for a small for a smaller inhibition network, the accuracy is lower, and here for as the number of objects is lower, the network with higher inhibition works best. We still have so many drawbacks of this algorithm, because as we can see, we have two apples and one cup that is present in the image, but the saliency map cannot capture two apples differently. It shows them as a single object, and hence we are only able to detect two different objects in the image. For the conclusion, we can say that use of an on-center off-surround recurrent network with input from some saliency map can be an effective method to model a bottom-up visual enumeration. But currently the model works only for a particular category of images where objects are spatially well separated and are fewer in number. For the future work, we will work on increasing the network size so that we can increase the resolution of the image and work for the higher number of objects, and include the mechanism for edge detection and contiguity so that we can recognize overlapping objects also. Adding a top-down regulation to network inhibition. Our network works with different inhibition value depending on the size of the numerosity of the images. Here, if we add a top-down regulation, depending on the already existing knowledge in the brain, then we can better estimate the number of objects in the image. We are also designing some studies regarding reaction time, adaptation, and influence of continuous property like size and density. For example, if there are some experiments which shows that if we increase the overall density, then keeping the numerosity fixed, our brain perceives it as a higher numerosity. So those kind of experiments are also required to do. Thank you very much for your time. I'll end the presentation here.
Thank you, Bhavesh. So there is a question in the chat. So this is by Amarnath. So in this paper, by numerosity, does the presenter mean the total number of objects? So can you clarify the task?
Yes, it's the total number of objects.
Okay. So another question that I had was, so can you elaborate on the idea where you were suggesting that it's only when the function between the set size and the activation is monotonic, you can estimate the number of items using the model?
Yes. So if the relation between set size and input number are not monotonic, so let's say we are talking about this region. If you can see the screen now. So in this region, for a specific mean activation, we don't have a particular input number. So the functional relation is not possible. Like for example, 0.4, we can have a corresponding input number as 2 and also as 25, because the curves are not monotonic. So
basically there's a region of set size for which your model won't be able to provide a estimate.
Yes.
Right.
So if you're talking about the set input number from 20 to 60, then we have to use an inhibition network 0.01, because then only we can have a pre-image, we can have an inverse function from mean activation to set input number.
Okay. So one more thing that I wanted to ask was, did you compare this with any other model of numerosity judgment?
Yes, we have compared it, but we have still not able to. We are collecting the data from different standard image set, and we are calculating the accuracy of this model.
Okay.
Here,
so,
our model is at a very beginning phase here, because we are only using saliency map information from the saliency map and leaving out all the other information from the images. So.
Okay. That's good. So are there any other questions? So, okay, Bhavesh, thank you so much for the presentation.
Thank you very much, sir.
Now, we will go to the next paper. The paper is titled Mathematical Modeling of Biochemical Networks in Neurodegenerative Diseases. Authors are Hemlata S. and Shyam Divakar. The paper will be presented by Hemlata. Both are from Amrita Mind Brain Center, Amrita Vishwa Vidyapeetham.
Good morning, everyone. I am Hemlata Shashidhara Kurup from Amrita Mind Brain Center. Today, I'll be talking on the topic mathematical modeling of biochemical networks in neurodegenerative diseases. So, the mechanism underlying neurodegeneration is connected to several other disorders, including Alzheimer's, Parkinson's, then multiple sclerosis or dementia. Most of the cases, these diseases are incurable. And one of the major reasons are the mechanism of the disease, especially from a cellular level, is poorly understood. Studies have shown that although aging is the biggest risk factor, genetic and environmental factors and their interplay are also involved. Also, the accumulation of abnormal proteins in the neurons can lead to neurodegeneration. The problems and challenges include lack of systemic studies that lead to neurodegeneration, then identification of relevant biomarkers, difficulties in laboratory experiments, etc. So the application of systems biology and using computational tools, we can relate some of the subcellular components of neurons to circuits and behavior. This study mainly focuses on two major disorders, Alzheimer's disease and Parkinson's disease. Alzheimer's disease mainly affects the memory and thinking skill due to the deposition of amyloid plaques and neurofibrillary tangles. Plaques and tangles, they are abnormal accumulation due to the structures due to the accumulation of abnormal proteins that may lead to neurodegeneration. So the figure shows the loss of neurons in severe and mild stages of Alzheimer's compared to a healthy brain. In severe condition, most of the neurons are lost. Parkinson's disease mainly affects the motor system, and it is linked to the loss of dopamine producing cells in substantial nigra, a brain structure in the midbrain. The affected individual they can have an inclination in their head and trunk and also experience tremor even in their resting stage. These are some of the cellular factors, genes and cellular factors involved in both these diseases. Lewy bodies, amyloid plaques, and neurofibrillary tangles are abnormal structures due to the deposition of protein, misfolded protein. These are the protein listed that cause this, the formation of these structures. Then TNF-alpha, glutamate, P38, and reactive oxygen species can lead to neuroinflammation and oxidative stress in neuron that can also lead to neurodegeneration. Studies have also shown insulin has role in neurodegeneration. So there is a need to reanalyze some of these reactions and how they are linked to each other, or whether they share common mechanism, or how these all processes are linked to insulin resistance. Mathematical modeling using biochemical systems theory helps to unravel some of these reactions and understand the mechanism of disease in a better way. So this study, some of the major biochemical reactions involved in both these diseases have been modeled using biochemical systems theory. Biochemical systems theory is a mathematical modeling framework that uses power law formalism, which facilitates the analysis of dynamic biological systems based on ordinary differential equations. So the biological systems can be considered as networks. So a single cell consists of hundreds of genes or proteins or their kinetic relations connecting to other signaling pathways. These are some of the equations used, kinetic laws used in the system. So by applying kinetic laws, we can produce time series data where you can analyze single entities or multiple entities in the system. The figure shows the computational implementation of feedback loop in TNF-alpha release during inflammation. So TNF-alpha can bind to its own receptor and create a feedback loop for its own production. Here, whatever coming into the system considered as positive and going out of the system is considered as negative. And K1, K2 to K6 are respective reaction rates. So all these reactions we can express as mathematical equation in terms of their concentration of reactants and reaction constants, and calculate the rate of change of particular entity and produce the concentration versus time graph and change how and analyze how changes in these entities can affect the feedback loop and production of TNF-alpha. So some of the model pathways were to understand the role of alpha-synuclein in dopaminergic cell death, then role of TNF-alpha in regulating neuroinflammation, oxidative stress and insulin pathways linked to Alzheimer's and Parkinson's, and also the insulin resistance in neurodegeneration. There are experiments available to curate the data required for this modeling. Some of them are listed here. They were through the literature survey. So the data were curated for both control and disease conditions and modeled them and compared and studied them. This is the part of the pathway that shows the dopamine synthesis model. So according to literature, dopamine transporter, DH-tyrosine hydroxylase or L-DOPA, they are common cellular factors that can be seen in brain. And neurofibrillary tangles or Lewy bodies, they are critical in disease condition. So all what I have done is to connect these reactions in the terms of reaction that can be studied studied in a system. So the model shows that alpha-synuclein is the major protein here that can modify some of these reactions that leads to the oxidation of dopamine, causing oxidative stress, or with other factors leading to the phosphorylation of tau, leading to formation of tangles, and aggregated alpha-synuclein can cause Lewy bodies and lead to neurodegeneration as observed in this case Parkinson's disease. This is another part of the pathway that shows the feedback mechanism of TNF-alpha activated by astrocyte and microglia. So they are TNF-alpha is released from these cells and they create feedback loop for its own production. Along with that, it also releases glutamate, calcium, then calpain, CDK, and some other inflammatory mediators such as IL-1 beta, IL-6. Not every protein is shown here, and this can also lead to Lewy bodies, neurofibrillary tangles, and oxidative stress that slowly lead to neurodegeneration as observed in the disease condition. Yeah, insulin resistance has a very important role in neurodegeneration. The model shows in normal condition, the binding of insulin to its receptor that regulates some other pathways in the normal cellular mechanisms, including glucose uptake. So any disturbance can lead to the dysfunction of these pathways or production of some proteins, including insulin degrading enzyme that stop the degradation of the amyloid beta or alpha-synuclein. They can aggregate together, form Lewy bodies, tangles, and they can modulate inflammation or oxidative stress or protein aggregation, or even TNF-alpha release and maintaining the feedback loop and leading to the neurodegeneration. So after modeling these pathways, some of these pathways were also, some of the predictions were also made to analyze the variations of protein levels. The dopamine model has shown that there was a decline in the dopamine compared to control condition. Then the tau protein, TNF-alpha, alpha-synuclein aggregation, Parkin and tangles, oligomers, amyloid beta oligomers or Lewy bodies, they were also slowly increasing in the disease condition. The model predicts that even though dopamine can be used as a biomarker for Parkinson's, we can also consider alpha-synuclein, amyloid beta, deglycase 1, tau, Parkin, LAMP2A, or insulin or other inflammatory mediators as biomarkers for these both diseases. Although the roles of these proteins are experimentally proven, there is a need to understand how they can be used to target for the disease. And especially in the case of some of these reactions, they need to be, the laboratory experiments need to be carried out to understand the dopamine oxidation, alpha-synuclein oligomerization, or feedback loop of TNF-alpha. Some of the proteins that involved in the proteomial degradation or crossed up between the proteins that lead to neuroinflammation or insulin resistance, so that it has to be targeted to get a clinical benefit. And the model also suggests the abnormal increase in Parkin, TNF-alpha glutamate, reactive oxygen species, or the decreased activity of dopamine transporter protein, then overexpression of alpha-synuclein and aggregation of the proteins, they all can be considered as and used as the biomarkers for the progression of the disease or to track the progression of the disease. So according to this model, it supports the existing hypothesis that dopamine pathway was highly impaired during the progression of Parkinson's disease. Then aggregated proteins such as alpha-synuclein, amyloid beta, tau, they can form some of these abnormal structures that can lead to degeneration as observed in Alzheimer's and Parkinson's disease. Then TNF-alpha, they can cause, TNF-alpha is a very important protein that can lead to glutamate-mediated excitotoxicity and neuroinflammation. Then insulin resistance has a major role in the along with this TNF alpha or protein aggregation or tau phosphorylation, they can also lead to neurodegeneration. The model shows mutations in alpha-synuclein, amyloid beta, and tau share common pathophysiology in both Alzheimer's and Parkinson's disease. The TNF alpha, Lewy bodies, and neurofibrillary tangles, or even low insulin levels can be common biomarkers for both these diseases. So this study was supported by the grant from Department of Science and Technology, Government of India. Thank you.
Okay, so we have time for one question. If you have any question, you can raise your hand or just type it in the chat. Okay, Hemlata, thank you so much for the presentation. So let us move on to the next speaker, who is presenting a paper titled Resting State Functional MRI Connectivity Alterations Related to Cognitive Changes in Intracranial Dural Arteriovenous Pistulus Before and After Embolization Treatment. The authors are Sabrish Shekhar, Santosh Kumar, Sushma Ramachandran, Ram Shekhar and Menon, and Vijay Thomas. Paper presenter is Sabrish Shekhar. All of them are from Sri Chinta Tribunal Institute for Medical Sciences and Technology. Please go ahead. If you have any questions, just please write them in the chat directly to me.
Good day to you everyone. Today I am going to present a topic on resting state functional MRI connectivity alterations related to cognitive changes in intracranial dural arteriovenous fistula before and after embolization treatment. This study was conducted in Department of Imaging Sciences and Interventional Radiology, Sri Chitra Tirunal Institute for Medical Sciences and Technology, Trivandrum, Kerala. I thank my guide Dr. Vijay Thomas and other co-authors for giving opportunity to present this study in this forum. The study was supported by grants from the Institute TDF project and a DST Government of India. The study is now published as full paper in JMRA 2021. Here we present a small part of our study, which may result in furthermore new research and results related to this topic. Intracranial dural arteriovenous fistula characterized by abnormal arteriovenous shunt at the layers of the cranial durameter, which is applied by the meningeal branches. It constitutes up to 10 to 15% of the intracranial vascular malformation, and it's more common in temperate countries like India, with the CVT being the underlying common risk factor. The disease presents a spectrum of symptoms, from the benign symptoms, which may include headache, tinnitus, to the aggressive symptoms, which may include the hemorrhagic or non-hemorrhagic symptom. Among the non-hemorrhagic symptoms, dementia is the most common symptom. It contributes up to 25% of the clinical presentation. Here we can see the three different patients. First one is the patient with a transcutaneous sigmoidus dural fistula, presented only with the headache and tinnitus, whereas the patient with the superior sagittal sinus DAVF and a temporal DAVF presented with a subacute onset of the progressive cognitive decline. So cognitive decline in the dural fistula is related to venous congestion and congestive encephalopathy, which results in cortical or thalamic mediated mechanism for the cognitive decline presentation, but no single imaging predictor for the initiation, progression, and reversibility of the cognitive decline. So, the resting state fMRI is a spontaneous fluctuation of the brain activity at the state of rest. Similar spontaneous fluctuation of the low frequency bold activity signals said to be functionally connected, even though they are anatomically distinct. Resting state networks are the spatially distributed but functionally connected, strongly linked subregions of the brain. So these are all the resting state networks. Some cognitive specific resting state networks include default mode network, salience network, frontoparietal network, and a dorsal attention network. So by studying about the interaction among the resting state network, we can know about the symptomatology, the disease-specific functional connectivity changes, pathological mechanisms, and to know about the early changes later to the disease. So the aim of our study is to evaluate the resting state networks, functional connectivity changes associated with dural arteriovenous fistula and its correlates in reversible cognitive decline after treatment. So we have included 33 patients of newly diagnosed dural artery venous fistula and equal number of the age and gender matched healthy controls from the local community. All the patients and healthy controls are underwent baseline resting state fMRI followed by the complete battery of neuropsychological evaluation. Among the 33 patients, 20 patients underwent endovascular management for the dural artery venous fistula, underwent interval follow-up 1 month resting state fMRI and a neuropsychological evaluation. So the coming on to the analysis, the neuropsychological scores between the patient and healthy control are compared using ANOVA test. The patient group in addition is divided into high and low neuropsychological scores depending upon the neuropsychological performance to know about the strength of the functional connectivity with that of the neuropsychological scores. Coming on to the functional connectivity, initial structural data was processed using SPM toolbox followed by functional connectivity done using the CON toolbox. A bandpass filter for the low frequency cutoff made into 0.008 to 0.09. All the resting state data analysis are done using group independent component analysis with voxel-based parametric t-statistics for the F-test. In a group IC analysis, initially the spatial map was obtained from the healthy controls. Then from the healthy control spatial map, the particular network of interest, that cognitive specific network of interest are identified by the visual inspection. Followed by that, group IC analysis between the different groups are done. Coming on to the results, when we are considering the demographic characteristics between the patients and the healthy controls, there is no statistical significant difference. In clinical presentation wise, benign symptom contributed to 45% of the patients. Among the aggressive clinical presentation, cognitive decline was noted up to 30% of the patients. Coming on to the neuropsychological scores between the patient and the healthy controls, patients showed decrease in the neuropsychological performance in all domains of the neuropsychological profile compared to the healthy controls. In post-embolization group, there is improvement in the neuropsychological profile compared to that of the pre-treatment group. But when we are comparing the post-treatment group with that of the healthy control group, that improvement in the neuropsychological profile is suboptimal at the 1 month follow-up. When we are considering the functional connectivity analysis, group IC analysis for the default mode network showed decrease in the functional connectivity noted at the precuneus posterior cingulate region when comparing to that of the healthy controls. When we are considering the neuropsychological profile of the patient with the low neuropsychological performance showed the more decrease in the functional connectivity compared to that of the high neuropsychological patient group. And post-treatment group, that low decreased functional connectivity is less prominent. When we are considering the post-treatment group with the pre-treatment group, the patients with the post-treatment group showed the opposite, that is increase in the functional connectivity at the precuneus posterior cingulate region. When we are considering the salience network, decreased functional connectivity noted at the anterior cingulate region, which is more prominent in the low neuropsychological score groups compared to that of the high neuropsychological score groups. The post-treatment group, there is an opposite functional connectivity, that is increase in the connectivity is noted at the anterior cingulate region. In the frontoparietal network, there is an increase in the functional connectivity noted in the precuneus posterior cingulate region, which is more prominent in the high neuropsychological score group compared to that of the low neuropsychological score groups. The post-treatment group, that is opposite change, that is increase in the connectivity noted in comparison with the pre-treatment group. In the dorsal attention network, that's increase in the functional connectivity noted in the rostral prefrontal cortex, which is more prominent in the high neuropsychological score groups compared to that of the low neuropsychological score groups. The post-treatment group, that is an opposite changes, that is decrease in the functional connectivity is noted at these regions. When we are considering the statistical analysis, wise also all these functional connectivity changes are statistically significant, and quantitative wise also this connectivity cluster changes significant, and it shows the strength of functional connectivity changes correlates with the neuropsychological profile. So in short, in the dural arteriovenous fistula, the resting state functional connectivity changes are related to the cognitive decline, and the strength of the functional connectivity changes correlates with the neuropsychological scores of the patients, and the reversal of the functional connectivity changes towards the baseline noted after the treatment. Thank you.
Thank you. So are there any questions? Please let me know. So Sabrish, are you there? So,
yes, sir. I am there, sir.
So I had a slightly unrelated question. So I'm not really familiar with the problem that you were talking about. So I was just interested in knowing a little bit about the kind of cognitive declines that you observe.
Actually, this condition is more common, sir, in India. We are coming across many cases. It is more common in neuroradiology practice, actually. That patient will present with varying symptoms. But whatever we observed was that most of the patient has some amount of cognitive decline. When that they are presenting at the later stage, they will have significant cognitive decline. So that is why we and
any
other
specific thing, Sabrish, that you would want to point to? For example, when you also talk about the treatment, right? So is there alleviation in all kinds of cognitive declines?
Actually, it is a very dramatic improvement will be there after the treatment. So we wanted to know what is that. So in between that pre and post treatment, how is that changes are there? Since it can be in a short term, how is that changes are there? So it may we can understand about that transient changes in the networks which is happening before and after treatment.
Okay, Sabrish, thank you so much for the presentation. Let me call the next presenter. The paper is titled Modeling Joint Torque Estimations for a Lower and Upper Limb Based on Accelerometer-Derived Gait Data for Assistive Exoskeleton. Authors are Abhijit Balachandran, Chaitanya Nutakki, and Shyam Divakar. Sorry if I'm pronouncing it wrong. So from Amrita Mind Brain Center, Amrita Vishwa Vidyapeetham, presentation is being made by Abhijit. If there are any questions, please write them in the chat window.
Okay. My name is Abhijit B. I am from Amrita Mind Brain Center, Amrita Vishwa Vidyapeetham, Amrita. Today, I am going to here to speak about the topic modeling of joint torque estimations for a lower and upper limb based on accelerometer-derived gait data for assistive exoskeleton. What is gait and its application? Gait is a manner of walking or pattern of walking. And it is said that just like fingerprint sensor and our facial recognition, every walking pattern is unique for each and every individual. Now, application of gait is in various fields such as clinical field, sports field, and in the field of security. Then we have different types of ways in which the gait can be measured. Some of the ways are accelerometers, video capture, and force plates and gyroscope. And here you can see the image of accelerometer sensor that is placed on inside a phone. And this accelerometer and gyroscope is the two sensors that which we use for our further studies. Now, the aim of the study. The goal of the study is to model required torque joints and forces during anticipation, preparation, and execution of foot movements using sensors that can maintain dynamic posture and coordination during a movement. And here average torques of different joints that contribute the balance and regulations of the movement initiation was calculated using smartphones. Here this figure represents the ball and stick joint which we have used to attach smartphones to collect the data. In each sagittal plane, there are 6 joints, that is shoulder, elbow, wrist, knee, hip, and wrist. And Here, this diagram represents how the data is being collected. Initially, these phones are being attached to the subject, and they were asked to wait for 10 seconds so that the initial movement can be calculated, resting move. Then after giving a go cue, the subject started to walk. We carried out this experiment in 40 subjects, of which 20 are female and 20 are male. And each subject carried out 3 cycles. Now, then we calculated the average stride and step. This table shows the average stride length, stride width, step length, and step width. Now, gait phase analysis and modeling. These are the equations that we use to calculate the torque, amplitude, and torque force acting on each joint. And after extracting the data in the real time from the smartphones, then we process the data. Then data selection normalization is carried out, which is the data pre-processing phase. Then we carried out to the gait recognition phase. Then finally we moved on to the modeling phase. Now, this is these two images shows on the left side. It shows the torque amplitude comparison between the left upper sagittal, which is shoulder, elbow, and wrist, and lower left sagittal, which is hip, knee, and ankle. On the right side, here we can show the torque amplitude comparison between the upper right sagittal and the lower right sagittal. And here you can see on the x-axis, it is the number of joints, versus the y-axis, it's the average torque amplitude. And error bar indicating the standard deviation has been marked. Now, the comparison of different joint torques, different torque amplitude of male and female gait. Here on the left side, here we have compared the torque amplitude comparison between left and right sagittal halves of a body of a male and a female. Then on the right side, we have compared the torque amplitude of we chose the torque amplitude difference in the hip and angle of the male and the female. Here on the y-axis, it is average torque amplitude. On the x-axis, it is joint position. Now, we carried out the classification of gait kinematic data using different machine learning algorithms. Here in the table, these are the different machine algorithms that has been used. And with the, we have used a different percentage of split, that is 60% and 70% of the split. And you can see different values. Then we moved on to, we analyze the key features and optimize the parameters that contributes the best for classifying the gait parameters. Here in this table, we have showed you the active kinematic features during the swing and the stance. Here you can see the table. Classifier attribute, hip, knee of each different joints. Then after then we apply the feature selection filters, which are namely classifier attribute, correlation attribute, and gain onto the evaluators to estimate the role features assessing the stance and the swing. Then to discriminate between the left lower and right lower, hip and knee attributes were most crucial. And for upper body estimations, we used the wrist and shoulder, which shows the prominent features. And for the collateral joint kinematics. Discussion. Joint torque, amplitude, and variations among the different joint combinations during swing and stand phase and in progressive phase gait could suggest a new biomarker for each joint according to the person height, weight, etc. And the capacity to expand the gait-based reconstruction of human walking by translating the joint kinematic data classification and performing torque analysis in real time, which enable the future prosthetic devices according to our findings. The conclusion and future aspect. This study also been extended to the clinicians to identify the markers for normal and diseased conditions, and brain-machine interfaces, cybersecurity, and gate-based biomarkers, image-based reconstructions of a body mass kinematics. Then, and lower body correlations, assessing and exploring the critical features within the gate using classification and inverse dynamic analysis. Thank you.
Okay, thank you, Abhijit. So we have time for a few questions. The first question is by Amarnath. He's asking, what is the difference between stride and steps? Can you elaborate on it?
Stride is when we move.
Step, stride and step.
Stride is the movement one cycle, like one step. If we start from left, then we move forward, and then another people, another. So when we move forward, then another.
Sorry, Abhijit, your voice is not clear.
Okay. Hi, I'm stepping in for Abhijit here. He's been part of evaluating over late night 300 art proposals last night. So I'm going to support him in this case. Stride is more about the distance between both right and left foot when we take the steps that we take. Whereas when you look at a step, when we analyze gait as a step approach, we only look at one part of either front or the left step. Sorry, the left or the right step. One of the directions, anatomical directions moving.
Okay. So are there other questions? Please let me know. So meanwhile, I'll ask a question. So one of the things that I was wondering was, because what you guys are using in the study are these phones, which are somewhat chunkier compared to normal sensors that we use. So would you expect that it would influence the actual gait you would obtain when recording? And if yes, is there a way you validated whether what you're measuring is indeed a normal human gait?
So, okay, I can't hear him, so I'm going to talk on behalf again. This data is pre-pilot data to what we got as a grant to initiate the real study. So basically, our idea was to go, we work very attached to a big hospital here, 1,600 beds. And one of the problems we see is our rehab doctors come and tell us, Dr. Ravi, who heads the physical rehab, comes and tells us, we need a very cheap solution that you can throw away, that when people walk in, we can use on it. So we started thinking, why not use a single mobile phone and see whether what hand-based gadgets like this can do. And we ended up with attaching a mobile phone which was very chunky, very unreliable, very noisy, and probably even you have to do a lot of temporal correlations before you start the analysis, which we did with an app, and we tried regulating something. But the real story is that you may have to actually build, the goal is that use that as a pilot data to see the viability and then build something that you actually have to have in field. So answering your question, what we have done is only a preliminary step to say, probably it's working. But when we really think about it, it should be elegant, like you said. It should be poised at the right location, which means that you need to have a right kind of a measurement, and every person changes. So you need to have a average relative reference internal model that is assessed by the system. And then, of course, the GPS and the accelerometer and all the other basic phenomena that you need should have easy calibration standards. So yes, right, it's a very preliminary pilot data, and now it's actually part of a CSRI funded project. We took that data to prove that this is viable, but we are in the process of actually reanimating the entire process.
Okay, thank you so much. So thanks, Abhijit. Shyam. So we'll move on to the next presenter. Study is titled Locality Effects in Processing of Argument Structure and Information Status Using Reading Aloud Paradigm. The authors are Rupesh Pandey, Siddharth Ranjan, and Raj Krishnan Rajkumar from IISER Bhopal. Rupesh will be presenting the paper. Please send your questions in the chat.
Hello everyone. I am Rupesh Pandey, a research scholar at IISER Bhopal. I am presenting my work locality effects in the processing of argument structure and information status using reading aloud paradigm. This work is in collaboration with Siddharth Ranjan and my supervisor, Professor Rajakrishnan Rajkumar. This work deals with scientific hypothesis testing and the development of annotated speech corpus. Let's move to the motivation part. The spontaneous speech is a different phenomenon than reading aloud. It is the spontaneous flow of speech in which the orator plans the contents simultaneously with the process of speech. In contrast, reading aloud is a three-party process. It involves all the four usages of a language. In reading aloud, the orator reads out the given content, which already written by someone else. Hence, the cognitive load on reading aloud is comparatively lesser than that in spontaneous speech. Dual root cascaded model is a model demonstrating the process of speech production. It was given by Coulthard et al. In 2001. If we look at the right side, it demonstrates that how the visual input is processed and gets converted into grapheme and phoneme and ultimately produced as speech sounds. The semantic block in the left side shows that speech can be processed with or without the involvement of comprehension phenomena. So these are our hypotheses. First is frequent words are processed faster. This hypothesis was tested by Coulthard in 2001 for English words in isolation. We tested this hypothesis for Hindi words in sentences. Second is processing cost defined by dependency locality theory, model reading aloud time in Hindi. Third is arguments are processed faster than adjuncts. And the last and the final, words at topic position are processed faster than words at focus positions. Let's move to the background section. Arguments. Arguments are the necessary linguistic information in a sentence, whereas adjuncts appear optionally. If we look at these examples, the verb read is a transitive verb, hence it requires a direct object as an argument. So there are two arguments, subject and an object. The verb give is a ditransitive verb, hence it requires a direct object and an indirect object to complete the sentence. So in this sentence, John, Maria, and pen are all arguments. Dance is an intransitive verb, hence it only requires a subject argument. It does not require any object argument. So these arguments and adjuncts were annotated on the basis of the role of the NPs in the sentence. So the constituent NPs, which are immediate constituents to the verb, were annotated as adjuncts, arguments, and those NPs which are not immediate constituents to the verb were annotated as adjuncts. Butt and King in 1996, according to them, topic has the background information and it generally occurs at the sentence initial position, and focus is the new information in a sentence. Generally, it occupies the penultimate position or the pre-verbal position in a canonical Hindi sentence. It fills the informational gap. So if we look at the example, Nadia ne Hasan ko kitab di, Nadia ne occupies the topic position and kitab occupies the pre-verbal position or focus position. Storage cost is the energy required to store the incomplete dependencies in a sentence in terms of memory units. And in contrast, integration cost is a backward-looking cost, which quantifies the energy required to integrate the current word with the previously occurred incomplete dependencies in a sentence. So this image here illustrates how integration costs and storage costs are calculated. Let's move to the experiment part. For the data, we took Potsdam Allahabad eye tracking Hindi corpus. It consists of 153 sentences, which corresponds to 2596 words. There are 421 arguments and 367 adjuncts. So we called two native speakers of Hindi for the process of data collection. So they were given the sentences to record. So they had to record each sentence and upload the recording file using a Google form. And each sentence was followed by a comprehension question to make it sure that they are not just mechanically reading the sentences, but the process of comprehension was also involved. Data was processed in this way. So each audio file was annotated using Pratt software. Reading time was extracted using a Python script. So reading time of each word was normalized by dividing them with the word length, and we used R programming language for the process of data analysis. This is the illustration of how each audio file was annotated at word level and sentence level. So coming to our result, our regression result shows that the factors word length, word frequency, integration cost, storage cost, and information status, all these factors are significant predictors for word duration. The negative sign of p-value shows an inverse relation with the predictor and the word duration. So yeah, significance is denoted by t value greater than 2. So if we look at the result, word length is a significant factor which shows that higher the word length, higher will be the reading time. Word frequency has an inverse relation with the reading time. It shows higher the word frequency, lower will be the reading time. Integration cost and storage cost are also positive. It means that higher the integration cost and storage cost, higher will be the word duration. When we compared the mean values of reading times of adjunct and arguments, we did not find any significant difference between them, as suggested by the argument and adjunct, as suggested by the regression result. We find that we got an inconclusive result. So we can say that arguments and adjuncts are processed similarly. When we compared the mean values of focus and topic, we found a slight difference. We found that topic has a higher reading time than a focus word. So looking at the regression results, we found that for topic, the t-value is greater than 2, and the positive sign here shows that words at topic position are processed slower than words at focus position. So discussion, the possible reasons for the observed trends. So first is final position of the verb not encoding arguments. If we compare the two languages, Sudha eats a mango in the garden and Priya ne Umesh ko kitab di. In English, verb occurs in the beginning just after the subject. Hence, we can say that it provides facilitation for prediction of the upcoming words or objects. In contrast, in Hindi, verbs occur at the final position, thus no scope for prediction of the upcoming word. Hindi also allows flexible word order. Sudha ne Ramesh ko dukaan mein kitab di and Ramesh ko Sudha ne kitab dukaan mein di. We can see that the position of subject and objects are interchanged without any change in the meaning of the sentence. Interference effect is also there. Sudha ne Riya ko Priya se kitab lekar Anu ko dene ko kaha. So the appearance of the case marker ko several times in the sentence may cause processing difficulty. Locality effect. So increasing the distance between the arguments and head increases processing difficulty. And T-locality effect is also there. It says that sometimes interposing material also facilitates prediction by providing ample time to predict the upcoming word. High storage cost and integration cost is also there. As we saw that storage cost and integration cost are significant predictors of word duration. Coming to conclusion, frequent words are processed faster than non-frequent words. Yes, this hypothesis was validated according to our results. Processing cost defined by DLT, model reading aloud time in Hindi. This hypothesis was also validated. Arguments are processed faster than adjuncts. So unfortunately, we did not get any significant we did not get any conclusive result for this hypothesis, and words at topic position are processed faster than words at focus position. As we got significance in the opposite direction, this hypothesis was rejected. So this is our plan for future, and these are the references. Thank you.
Okay, thank you, Rupesh. So there are two questions. First question is by Saloni. So she's asking, which are the basic computing languages which we can use in the field of cognitive science?
Sorry?
So Saloni is asking which are the basic computing languages which we can use in the field of cognitive science. I guess she means more in terms of analysis point of view. So
Yeah,
Saloni,
we
can you
used.
clarify?
Hello.
Please continue.
Yeah. Is my voice audible?
Yes.
So yeah, it depends on what kind of analysis we need. So we used Python as well as R for different purposes. So yeah.
Okay. So the next question is by Amarnath. He's asking, how do you calculate the integration and storage cost? For example, when you say integration cost is 8, what does that value mean?
Yeah, integration cost and storage cost, like these quantities, like these are estimation of the amount of energy required to, like based on the incomplete dependencies. It depends on the number of intervening materials between the subject and the head, or we can say the verbs in the sentence. So storage cost is a forward-looking cost. So after if we look at a sentence, so once a subject appears, it looks for a verb. So in between whatever, so the number of intervening materials, they quantify the storage cost. And integration cost is the sum of the energy required to integrate the verb with all the incomplete dependencies which has already occurred in the sentence.
Okay, so
it's based on the number of intervening words.
Okay, so there's another question. Do authors have authors seen any significance with respect to non-native Hindi speakers?
No, we have not checked for non-native speakers. So our study include only native speakers of Hindi.
Okay. So are there any other questions? So thank you, Rupesh, for the presentation. So we'll move on to the next paper. So the next paper is titled The Impact of the Second Wave of COVID-19 on Indian Students and the Mediating Roles of Psychological Flexibility and Coping Strategies. The authors are Aditya Jain, Rishabh Singhal, and Priyanka Shrivastava from Perception and Cognition Group, IIIT Hyderabad. Aditya will be presenting the paper. Please.
Hey everyone, this is Aditya Jain. I'm a student at the Perception and Cognition Group of IIIT Hyderabad, and I'm here to present my work on the topic of the impact of the second wave of COVID-19 on Indian students and the mediating roles of flexibility and coping strategies on this impact. So to introduce the topic, India was hit very severely by the second wave of COVID-19 from April to June 2021, with daily cases rising exponentially. India had become the country with the third highest number of cases during the second wave. With schools and colleges shut, students were forced to deal with online schooling, social isolation, self-enclosed ones getting infected, and the uncertainty regarding personal goals, since major exams and job offers were either deferred to next year or cancelled. Previous studies have found that these detrimental effects of the pandemic-imposed environment, but there have not been many studies in India, especially with a focus on students. We aim to detect the specific environmental factors created by the pandemic that impact these students' mental health and attention capacity, and understand the psychological mechanisms that exacerbate or mitigate this impact. In this study, we specifically looked at two mechanisms, one being psychological flexibility and the other being coping strategies. First, we go to the factors of the environment. Previous research had shown that COVID-19 and its impact on mental health have highlighted multiple risk factors. For example, longer quarantine durations have seemed to negatively impact mental health. Having close ones or you yourself getting infected has a link to increased stress. And the environment at home, for example, how much personal space you get or how many fights happen at home, has also seemed to influence mental health. Coming to psychological flexibility, it is the ability to recognize and adapt to a variety of situations. Previous research has shown that higher levels of psychological flexibility predicts overall better mental health. In context of COVID-19 specifically, studies have shown that psychological flexibility is one of the most key resilience variables in fighting against mental health problems. Furthermore, flexibility has been demonstrated to buffer the negative impact of recent life stressors on health and well-being, which is very relevant in the current setting of COVID-19, especially with respect to the second wave in India. Coping strategies can be categorized into two broad styles. One is approach coping, which refers to the attempts to handle a situation by actively seeking help, taking tangible steps to remedy the problem, or reflecting on alternative solutions. On the other hand, attempts to retreat from or deny the reality of the stressor, avoiding pursuing solutions, and striving to regulate emotions are all examples of avoidant coping. Previous studies have seen that individuals who tend to employ avoidant coping have lower mental well-being. One main goal of the study was to employ both flexibility as well as coping style measures to see how both of them interact and influence mental well-being in the context of students surviving COVID-19 second wave in India. So this was the experiment design that we went with. Initially, we started off with some demographic and environmental variables, which basically age, gender, education, and these list of variables that try to capture the environment that the student was going through during the second wave of the pandemic. And coming to the outcome variables, we employed General Health Questionnaire 12, which is a 12-set questionnaire that tries to measure psychological distress. We went with Patient Health Questionnaire, which is a questionnaire for depression. We went with CSSQ7, which is basically a questionnaire for stress that's specifically for students. And for the attention, the cognitive variables, we measured two attention things, which is sustained attention and selective attention. Sustained attention was measured using SART, and selective attention was measured using Stroop. Coming to the predictors, Compact-8 is a questionnaire used to measure psychological flexibility. Brief Cope is a questionnaire used to measure your avoidant and your approach coping. And COVID-19 Impact Index is whichever variables among these environment variables turn out to correlate with these health variables, we amalgamated them into one index and formed our own COVID Impact Index. We will get to that in some time. So in our study, 290 intermediate and college students, which were 71% men with a mean age of 18.8, were recruited for the study via snowball sampling, social media, and college mailing lists between 30th May and 22nd June. The study took around 30 minutes to complete and was hosted online on LabOnes. Participants were paid 100 rupees as an incentive. Coming to the descriptive stats or participant profiles, 71% of the participants were male and 48% of them were college students, while the rest were intermediate students. Coming to the effects of COVID-19, 30.7% of our participants were infected with the virus themselves. Moreover, almost 90% of the participants were either themselves infected or had a family member or friend infected as well. And out of them, 32.4% had a death of a close one, which showed how far-reaching and severe the virus was in India during the second wave. Participants gave an average rating of 3.5 out of 5 when asked how much they worried about the effect of COVID-19 on their lives. 65.5% of the participants were distressed according to GHQ, 37.9% were screened for depression according to PHQ, and 68.6% were moderate to highly stressed according to our stress questionnaire. These results reflect the severity of the pandemic's mental health and personal life impacts. Our sample also turned out to have significantly higher distress scores than those even seen in the general population during the second wave, indicating that even among the second wave studies, students were impacted way more than the general population. Coming to correlational analysis, we detected 6 environmental factors, which are listed here, that were significantly associated with the outcome health variables and were used to form the COVID-19 Impact Index. This index that we formed had very moderate positive correlations with our distress variable, our stress variable, avoidant coping, and had negative correlations with flexibility. Coming to flexibility, flexibility had significant negative correlations with all 3 of our outcome health variables, while avoidant coping had significant positive correlations with all 3 of our outcome health variables. This suggests that flexibility correlated significantly higher with better overall psychological health, while the COVID Impact Index and avoidant coping correlated with overall worse mental health. Coming to our attention variables, sustained attention correlated negatively with stress, while selective attention correlated negatively with distress and depression, showing the negative effects on students' attention capacity as well. These are the correlation graphs that you can see later. Coming to regression analysis, we wanted to see how well the predictors could predict the outcome variables. So we ran 3 regression models, one for distress, one for depression, and one for stress. With all variables entered, 42.5% of the variance was accounted for in distress, whereas 14.4% was for depression and 28% for stress. Results showed that predictors account for a moderate portion of the variance among distress and stress. Unfortunately, the prediction for depression was low since we used a screener questionnaire instead of the entire questionnaire. We used PHQ-2 instead of PHQ-9. In the model for psychological distress, flexibility and approach coping had small negative associations, while the COVID impact index had a small positive association and avoidant coping had a moderate positive association. In depression, psychological flexibility had small negative associations, while avoidant coping had small positive associations. And in the model for stress, the impact index and avoidant coping both had small positive associations. Mediation analysis was run for both the distress variables and the stress variables because those were the ones that correlated with the impact index. In the model for the distress variable, the relation between the impact index and distress was significantly mediated by flexibility and avoidant coping. If you look at the pathways, flexibility mediated a decrease in distress, while avoidant coping mediated an increase in distress. Similarly, when it comes to stress, the impact index, the relation was mediated by avoidant coping alone, which mediated an increase in stress. So in conclusion, this study showed the severe impact of COVID-19 on students in India. These effects are clearly reflected in our sample. Almost 1/3 of our sample experienced death among their close ones, and 30% were infected themselves at some point in time. Only 11% never got infected and had no close ones infected. It detected factors like length of lockdown, lack of personal space, increased fights at home, infection of self and closed ones, and general worry about COVID as detrimental to mental health. It also showed psychological flexibility as a resilience mechanism that mitigates this detrimental impact, while avoidant coping strategies exacerbated this impact. These results support interventions and approaches that promote flexibility, like ACT. Knowing the specific factors of environment that affect mental health may also contribute to the development and testing of these approaches. Some limitations of this work was that this was cross-sectional in nature. We can incorporate longitudinal studies for the future. Another thing is a lot of these reports were self-reporting, and the information obtained to encapsulate the environment may not have been exhaustive. We can always have a longer list of demographic variables. Lastly, the online nature of the survey may have led to slight inaccuracies in recording of response times. Thank you.
Okay, sorry, the microphone was on mute. So are the authors for this paper in the participant list? Because we have not been able to identify the account. Can you please raise your hand? Okay, it seems that the authors are not there. So if there are any questions, you can directly contact the authors and get them clarified. So should we move on to the next presentation?
Yes, Professor, we can move to the next.
Sure. So the next presentation is, the next paper is titled Procrastination and Progress Effort, Characteristic of a Task by Preetham Laskar and Nishit Srivastava from IIT Kanpur. Paper will be presented by Preetham. Please go ahead. Please send your questions to the chat directly to me.
Hello to everyone. I'm Preetham Laskar from Cognitive Science Department of IIT Kanpur, and I'm going to present a paper on procrastination and the progress effort characteristic of a task. So procrastination is the all too familiar behavior where people put off things, important things, for later with suboptimal outcomes. It's irrational in the sense that later on we regret having wasted our time and feeling that we could have utilized our time more effectively. We do it for a variety of tasks, from paying bills, booking flights, studying for a test, and I did it while making this presentation as well. So procrastination is intertwined closely with motivation, because how motivated we are to work on a task predicts how much we will spend, how we will spend our time on. So temporal motivation theory gives us a account of motivation where it depends on a number of factors. one of the main factors is value, obviously. So a task which has higher reward will have more motivation as compared to a task with a lower reward. The expectation term is here a probability, and it's a subjective probability that an individual has of how likely he or she will be able to finish the task if she tries to do it. So even if a task has a very high reward or value, but if we feel like we will definitely not be able to finish it, so the motivation remains low. And the important bit in the denominator is the sensitivity, is the time to the reward or time to a deadline. So the further away we are from a deadline or from the rewards of a task, the less motivated we are to engage in it. And the impulsivity factor is just a subjective sensitivity to delay. Some people are more impulsive than others. So using the TMT equation, a number of common behavior can be explained qualitatively. So one thing is, why do we procrastinate or while studying for a test? So if we assume that distractions have a constant motivation, and which makes sense because we phones and other things we can distract ourselves with are always available at our hand, and they give us immediate pleasure. Let's assume that the test has a higher reward, which is and the test is at 100 units of time in the future. So as we can see, the distractions will have a higher motivation until a crossover point, which happens close to the deadline or close to the test. The other thing which TMT equation can describe is preference reversal. Far away from a test, suppose we have an option to go to a movie the day before the test. For 1 week before, we feel like, oh, we will never go to the movie. Obviously, we'll keep on studying. But as the movie night comes closer, the motivation to engage, to go to the movie increases and may overcome the motivation to study, even though the going to the movie has a lower value. So the kind of tasks we procrastinate on can be two types. So one is discrete tasks, such as paying a bill or buying a ticket. This just involves 5 minutes of our time, but still we end up procrastinating on it. So in our study, what we focus on are non-discrete tasks, where we need to put a sustained amount of effort to on a project, such as studying for a final exam, learning a new skill or an instrument, or working on an assignment. So what about such tasks? So such tasks may differ in how difficult they get over time. Some tasks start off easy and then get harder over time, HOT, and while other tasks may be easier and then may start off harder and then get easier over time. So personally, for example, I found learning to code very hard in the beginning, and it became easier over time. Whereas usually when working on an assignment, students attempt the easier questions first and then the harder questions last. So it's a task which gets harder over time. So for such tasks, we may plot the progress versus effort curves functions. So as we can see here, for an easier over time condition, this will be supralinear. It will be concave up, whereas for the harder over time condition, it will start off, well, we will make rapid progress with little effort, but then we have diminishing returns. So for such tasks with the progress versus effort curve, we define what we call the ease, which is basically the derivative at any point. So at any point, the derivative will give us a number which will indicate how much progress we will make for 1 unit more effort we put in it. So the higher the ease, that is the greater the slope of the tangent here, the easier will be the task at that point. So for such tasks which require a sustained effort, how do we calculate the expectation? So the expectation will not remain the same, but let's go through it. So expectation is a probability, so it will take a value between 0 and 1. And the expectancy that we will complete the task should be an increasing function of the ease. The more progress we make for every effort we put in, we see individual sees that he or she is making rapid progress, and he or she will be more likely, it's more likely that they will be able to finish the task. On the other hand, it should be a decreasing function of the total amount of task left. So if we are 80% of the task is left, and even if we are making rapid progress, the expectancy would be less. So we define a number here, x of omega. Here omega defines the effort, which is basically the total amount of task left divided by the rate at which currently we are making progress on the task. And this number isn't a probability yet, so we just define expectancy as a function of x with this equation. So with this equation, basically we can see that as x goes from 0 to large positive numbers, the expectancy goes from 0 to 1. So it becomes a probability. So we did some simulations with two tasks. For the easier over time task, we chose an exponential progress versus effort curve. And for a harder over time, we chose a log curve. And the constant alpha was chosen so that the total amount, total effort needed to finish both the tasks remain the same. And then we ran some 1000 simulations. So let's look at the ease for these two tasks. So for the easier over time task, the red curve here, it starts off hard. People make, the agent makes slow progress and the expectancy is therefore low. But as they make more and more progress, it gets easier, and then it quickly, the expectancy increases. On the other hand, for the harder over time task, we have a U-shaped curve. This makes sense because at the beginning, we are making rapid progress and we imagine that, oh, we will be able to finish the task. But then as we make more and more progress, it becomes harder to make any more progress. So expectancy decreases until we near finishing the task where, around 95% of the task is done. Even though we make a slow progress, now we believe that we will be able to finish the task. So using this expectancy, we run some simulations, and here we see the mean starting times of when the agent started to work on this assignment. So for the easier over time task, which starts off hard, as expected, the mean is much higher than the task which starts off easy and then gets progressively harder over time. However, the submission times don't show such an effect. And the explanation here is, even though the harder over time task, which actually starts off easier, has a lead and people start working on it, but the task which gets easier over time slowly catches up. And by the time the submission time comes, it's pretty much the same. So these were simulations, but currently we are running a behavioral experiment, which is still going. So there, some students in a course are given a task and the reward is 10% of the course credits. And there they need to play rock, paper, scissors against a bot. And they play as many games as they need to win 400 rounds. They are told that the bot plays dynamically and tries to adapt its strategy to beat them. And that depending on whether or not they figure out the bot strategy or the bot figures them out, the bot may get easier or harder over time to win against. So, but in reality, the bot does none of this. The bot really cheats. So beforehand, we have a probability of the participant winning, and this probability P changes as the participant gets closer to the target of 400 wins. There are three conditions: easier over time. Here, the probability P starts off low, and then as the participant keeps playing against the bot, it increases and they feel the bot is getting easier to win against. The converse is true for the harder over time condition, and in the same condition, the P remains the same, but we choose the P in such a way so that the expected total effort needed to reach 400 wins remain the same across all these three conditions. So the variable which, the independent variable which distinguishes these conditions are basically how the difficulty changes over time. Now, one problem in this study is that participants should have an idea beforehand of how the task will go, whether it will get difficult or easier. So since if they don't have no clue, then there will not be any difference in the participants, how they when they start. So therefore, there is a familiarization phase where the participants play against the same bot, but this time they just play till they win 100 rounds, and it takes around 20 to 25 minutes. So once this is done, the next day, the main phase of the task starts, and they get 1 week time, and they can, anytime they can work on it, and however much they want to work, they can, and save their progress. So they get 1 week time to do the whole task, which takes around 2 hours. So these are two representative curves. The orange one is basically the harder over time, and the blue one is easier over time. As you can see that based on the number of rounds versus wins, they meet up kind of. So what we observe is, when do the participants put effort as we get closer to the deadline? The x-axis is basically the time remaining to deadline, and the y-axis is the amount of effort they put in. So we need a measure of procrastination. Simply starting times and submission times don't give us a whole picture. We need to know what happened overall. Some people may start off late and then finish it much before than someone else. So to measure this procrastination, we take the area under the constant effort curve. So what the constant effort curve is basically this black line here, where we consider an ideal participant who puts in the same amount of effort each day, utilizing the whole of the time period to reach the goal. So this denotes someone who works at a constant rate and finishes it right at the deadline. So if a participant, for example, the participant here is below this curve, the area between these two curves we will consider to be positive. And here it denotes, it shows that the participant here procrastinated. She or she didn't work at a constant rate, and at the end she did all of her work. On the other hand, if the red line was above the black line, it would show the participant is diligent and gets right on to working on the task. So these are our predictions. The predictions are that for the starting times, this start times will be modulated by the condition, specifically the task which start off harder and then get easier over time. In this condition, participants will start working on the task later as compared to the task which starts easier and then gets harder over time. However, the submission times we don't think will be affected because, as mentioned, later on the later half, the easier over time task gets easier, and which overcomes the motivation to work on the harder over time task. And thirdly, our main procrastination measure of this area under the curve, this will be more for the easier over time task, which showing that on the task which starts off hard and then gets easier, participant will procrastinate more than on the task which starts off hard and then gets starts off easy and then gets harder over time. Thank you, and I'll take any questions.
Thank you, Preetam. So are there any questions? So if you have any questions, just type them in the chat. I'll ask them. So meanwhile, Preetam, I wanted to ask something. So, so when you are talking about the initial model where you did not really assume that there's a variation in terms of difficulty level, that's the basic model. There you talked about a value function, right? How value is associated with each of the options that you can do over time. So what would be the value function for tasks where difficulty actually changes? So is there a relationship between the two?
You mean between the original TMT, this equation, and the later one?
Yes.
So the value here is basically the reward you get on finishing the task. So the value doesn't change. What changes is how much progress we make to. So it's like a binary. If you finish the task, you get the reward. If you don't finish it, you don't get any reward. What the function which changes is how much progress you make in finishing the task as a function of the effort.
Okay. So basically, because they're given a hard deadline, hence the value function doesn't really change. It remains the same, irrespective of when they finish the task.
Yeah.
Okay. So and how exactly do you plan to take this idea forward?
So right now, in a week or so, the deadlines will be over. The participants are currently doing it, and once we get the data, we will just calculate this area under the curve for each of them, and also the starting times and the ending times, and we will see if it matches our predictions. So the independent variable here is the participants' reply in the familiarization phase of, we just ask them, do you think the bot got harder over time, easier over time, or stayed the same? So this will be the independent variable, the subject's idea of how the bot difficulty changes, and based on that we'll see if there's a significant difference between the three conditions.
Okay, Preetam, there's a question by Amarnath. So can you explain the simulation part of how did you do?
Okay, so in the simulation, there are two tasks, and we assumed a distractor motivation fixed at 10, which kind of makes sense because the distractions are always there. And we ran 1000 simulation. On each simulation, what happens is an agent calculates the motivation for the task and the distractor remains the same. And there are 100 time units till the deadline. And on each time unit, either they work on the task or don't work on the task. And the probability is proportional to the weight of the motivation. So basically, if the motivation for the working on the task is 10 at some point, and on the distractor is also 10, it's just a coin flip, 50-50 chance that on that time unit they will work on the task or not. And so in this way, the motivation for the easier over time thing is very low, much lower than 10, and then progressively increases. And the value of both the tasks are fixed, and the motivation we calculate using the modified equation there. So then we ran 1000 simulations for both the conditions, easier over time and harder over time. And then we just saw the histogram of when they started working on what time step they started working on the task, and also at what time step they did finish the submission. We, in the submission details, we removed the trials where they were unable to submit. If you include that, the easier over time condition, most of the time the agent didn't finish the task.
Okay, so thank you so much, Priya, for the presentation.
Thank you.
So let me move on to the last presentation for the day, titled Evaluating the ML Models for Mind Big Data Eye Magnet of the Brain Signals. Authors are Priyanka Jain, Mayush Panchpur, Soumya Kushwaha, and Naveen Kumar Jain from CDAC Delhi. Paper will be presented by Soumya Kushwaha. Please.
Good morning, ladies and gentlemen, and welcome you all. It's really great to be here. Thanks for inviting us. We are from CDAC Delhi, team of Cognitive Science. My name is Soumya Kushwaha, and I'm going to present on the topic ML models for Mind Big Data ImageNet of the brain signals. Human-machine interaction is frequently seen as a reflection of human experience, speech recognition, human activity classification, facial identification, sentiment analysis, and so on, all based on sound and sights. E.g., brain waves are a good example of this. The brain has a distinct pattern of electrical activity that comes from aggregate firing patterns of billions of individual neurons, depending on what a person is thinking, experiencing, or doing. This research focuses on comparing and implementing several machine learning and deep learning methods in order to achieve improved classification accuracy of EEG signals. EEG-based classification of brain activities evoked by images still demands efforts for further improvement with respect to its accuracy, generalization, and interpretation. Yet some characters of human brains have been relatively unexplored. Here is the pipeline of ML, DNN, and CNN implementation for EEG signal classification. We merged all the required files from 140,000 data files into this one single file to create a data frame. After that, we did the EDA part, and after that, we do the sampling for reducing the noise and filtering methods to perform good filter. And after that, data set divide into the training and testing set. After that, we do the feature extraction part. And after that, we apply some popular ML and DL algorithms and CNN also. And after that, we evaluate the performance of training and testing set. The dataset ImageNet of the brain recorded EEG data from a single subject viewing near about 14,000 stimulus presentation and 569 classes each for 3 seconds over a 1 period. It was recorded by the subject themselves with a single consumer grade EEG recording device that is Emotive Insight with 5 electrodes. The data is kept in a plain text format with one CSV file for each EEG data point associated with a single image. There is a word report txt file which has 3 files per row tab separated by category names, EEG image count, and synset ID. And signal from 5 channels are included in each file: AF3, AF4, T7, T8, and PZ. To reduce noise in signals, we use exploratory data analysis and experimented with several filters and sampling methods. To study attribute subcategory features and signals, we use the matplotlib package to visualize data features, plotted histograms, and pie charts. ED steps are mentioned as below. checked shape, fill null values, retain columns with at least then 90% data, drop unnecessary columns, class density reduction. We do the multivariate analysis as well as univariate analysis. But we found that there are too many target classes in data set, which may lead to significantly less accuracy, and the data is highly unbalanced, and too many class distribution also. And to correct these observed anomalies from data set, we have introduced subcategories or to replace these classes to reduce the class distribution and target problem in data set. With the unique image category are 569, and these unique image category belong to unique 29 category. That is 569 image category target classes are replaced with 29 target classes. These 29 target classes are further replaced with 9 target. Here is given the original distribution of target volumes, which are highly imbalanced. You can see that. Firstly, we undersample the majority classes by using the random undersampling. And after that, we oversample the minority classes by using the random oversampler so that we get the classes distribution in an equal manner. After that, we do the filtering. Butterworth filter, we use which is the signal processing filter with the frequency response in the passband that is as flat as possible. Applied Butterworth filter of order 2 using SciPy filter library for noise reduction in signals using high pass and low pass filtering methods, where sampling frequency 120 Hz given by in our data. We have used backward forward. After filtering, we prepare data for the final model. First, we shuffle the data frame to remove bias in classification and splitted data using from sklearn train test split, where test size is 30% of the data frame and remaining for the trained data set. After that, feature extraction we have used, which is a technique for reducing the amount of features in a data set. In this, authors have used time series feature extraction library for feature extraction, which is a Python library for extracting features from time series data. We have used this to extract different features on the statistical, temporal, and spectral domains. Here is the table for the model performance and comparison between the ML and DL models of algos. We have used the DNN, CNN, and LSTM for image classification using EEG signal. The output of the experiment, you can see that the highest accuracy is of the bagging classifier with 0.75, whereas in the DNN models, deep learning models, we get the accuracy 7.157 in the LSTM, and after that we got the 70.90 in DNN and 69.90 in CNN. Now, our second approach is pipeline of CNN for spectrogram images. Here, we did create a list of all the labels of spectrogram picture files. After that, we extract the target from the list, reduce the number of labels from 29 to 9, and shuffle this data to reduce biases. Images are converted in arrays and stored in dependent and independent columns are assigned. And these dependent columns were labeled categorically. After that, we divided in the training and testing parts, and augmented dataset is built using the data augmentation pipeline. Here we create a CNN model and evaluate it. And you can see the results of CNN models. Model 1 without augmentation having accuracy 10.23, and model 1 with augmentation 11.39, model 2 without augmentation 74%, and model 2 with augmentation is 18.62. Here is the accuracy and loss graph. You can see that. So the results obtained for a spectrogram image of CNN model with augmentation is 0.10 accuracy, and with augmentation is 0.1. So there are many internal hyperparameters, number epoch, number batches, loss optimizers, etc. We tried different epochs and batches. The loss function in our case was categorical cross entropy for different classes. We tried different dropouts like 0.2, 0.3, 0.5, and optimizers like AdaGrade, RMS prop in deep algos. We also added early stopping. Finally, in our research, we found that Deep learning models perform better than ML models for classification of EEG signals. Thank you.
So, okay, thank you. Are there any questions? Mayurish, there is a question by Amarnath. He's saying that this dataset is from 2013, and were there any other experiments and their results that were conducted before and after 2013? Most probably that is what he means, and their accuracy.
Sorry, could you please?
Sure, I'll try to rephrase
the. Yes,
I'll try to rephrase the question. So, Amarnath is saying that the data set is from 2013. So he's asking, were there any other experiments related to, or
yes,
most probably what
sure. There were
the same, and what was their accuracy? That's his question.
Yes. Actually, there were few experiments done on these types of data set, but actually we have taken 2019 version of that data set, which contain more of classes into it. And yes, there were accuracies into 50s as well as in 60s. So yes, there were 2 experiments done on these types of data set.
Okay, thank you. So are there any other questions? Okay, Mayuresh. So thank you so much for the presentation.
Yes, thank you, sir. Thank you, everyone.
I think this is the last presentation that we have in the session. So I'll ask the organizers to take over.
Thank you, Professor.
Thank you, Dr. Devpriyakumar, for chairing the session and handling it so well. And more than that, for keeping all the presentations on the dot. Thank you so much, sir, for being here with us today and giving us your time. Thank you.
Thank you.
And I would also like to thank Mr. Sandeep for the wholehearted support that you gave for the unruffled completion of our session. And my sincere appreciations to all the speakers of the talk session. You guys made it truly remarkable session with your interesting presentations. Thank you.
Thank you.